Hello everyone, you are welcome to this channel. Today we shall be discussing a special case of differential equations that are not easily resolved. Uh, we have been dealing with easily resolved kind of differential expression, but in this case they are not easily resolved. Let's see an example here. When we have y prime equals to 1 plus y multiplied by x, we can easily separate the variables or collect the like terms. So this is dy dx equals to 1 plus y multiplied by x. So we can easily collect all the 1 plus y under y to mean like this and collect x under dx. So this is easily separable. We call this separable ODE, separable ordinary differential equation. But there are some cases in which it's not easily resolved like that. Let's see an example here. 2x y prime equals to y square minus x square. There's no way you can collect all the like terms of y under the y or collect all the like terms of x under the x. So there's no way. Just try it. There's no way to do that. So as a result of that, we need to develop a concept. That is what? Reducing to separable form. Reducing to, because we cannot solve it practically if we don't separate the variables or like term or the terms. Reducing to separable form. So how does it work? It says if y prime can be expressed as a function of y over x, then we can reduce to separable form. So how does that work? Let u is equal to y over x, and that means what? Our y prime here, it does not become y equals to function of u. So u is equal to y over x and implies what? Y is equal to ux. If you want to differentiate that, y prime is equal to u prime x plus u. And what do we make out of that? We try to now say it means our function of u, which is our y prime, is now equals to u prime x plus u. And we can arrange that to be that what? U prime x multiplied by x is equal to function of u minus u. So we can easily now separate the variables here. How? You know u prime is equal to du, so du can now take all of the u function u minus u, and x can now go here with dx, will now become dx over x. So that is how we reduce it to separable form. So let's see an example to the expression we gave here. So the expression is to do what? Solve 2x y prime equals to y square minus x square. So as I've seen, that is not easily separable. So we have to reduce it to separable form. So let's simplify it first. It means y prime is equal to, you divide through by 2xy, y square over 2xy minus x square over 2xy. And if you simplify that, y we cut y here, we have y over 2x, and x we cut here, we have x over 2y. So as before in the concept, we say let u is equal to what? Y over x. And so if you substitute that here, what do we have? We have y prime equals to what? This is y over x, that is u over 2. And this is x over y, that is 1 over 2u. So, and you remember, y prime from this expression, u is equal to y over x, y equals to ux, and y prime is what? Y prime is equal to u prime x plus u. So now let's substitute the y prime here for this. Substitute it here. So it means what? U prime x plus u equals to this expression here, which is u over 2 minus 1 over 2u. So let's simplify. When you simplify that, you are going to have something like this. U prime x equals to u over 2 minus 1 over 2u minus u. And that will simplify to something like this. Minus u square minus 1 all over 2u. And that is what? Minus u square plus 1 all over 2u. So that is our u prime x. So that means we have now, it's now separable now. It's now separable. How? What do I mean? It means what? U prime x is equal to minus u square plus 1 all over 2u. So we can collect all the u function term to du. So it means du dx x is equal to minus u square plus 1 all over 2u. So let's collect the like terms now. 2u du over u square plus 1 is equal to minus dx all over x. So we have now collected the like terms. So it's now separable. That's what we actually mean. So when you integrate this, what are you going to get here? It means this one will be ln u square plus u times 2u, which we call this one. So therefore, we are going to have ln u square plus 1 equals to minus ln x plus the constant of the integration.